part we prepared for this, and we wanted to test what different kinds of supports will look like when we do our build simulation. So there's also lattice inside, as you can see, and then here we have wall supports, here we have a solid support, here we have a thick wall support, and here we have no supports. And so I take this to my build simulation. I can specify what kind of accuracy I want to use. This, of course, has a huge effect on the time it will take to calculate this. Material and a few other else goes to the super box. So this is the server I talked about. So you can see the slider here showing me how far the calculation is done, and I can go up every time it calculates another slice. I can go and see it. So I can already start and analyze my model because it is the distance of each point from where it was supposed to be to where it is after the printing. And I can show you something really nice with this. If we look at this support, at the thick wall support, let's make it a little nicer. 1 second. Okay. So if I take it down, it started out like this, and now I'm starting to move up the slices, and you can see it stays more or less in place. But then as it reaches the part, you can see it starts to bend towards the part. So you can actually see the deformation of material as the printing goes. So as I said, when we have areas that are not supported well, we would expect to see recorder interference, the material going up. And if we go to this layer, for example, we can see it very clearly here. So usually anything around 0.02 millimeters will already be a problem. So we have that here, and it's likely that we will damage our equipment if we don't support this hand of the part. You can see this doesn't happen anywhere where we have supports. So that's a good example. Here, it's even in this layer, it's even worse because the material is. So this is the stress analysis. Again, we can see it in different layers, exactly what happens and how the stress changes as the part is being built up. And more importantly, a little bit above that, but this part definitely has problems because it goes quite high. And of course, you can see it's worse where we have no supports. And you can also see it's very severe here with this very thin support. And actually, this is very likely to be torn at this point. So, of course, we would need to add more supports. Also asked to see what happens when I cut it away from the build plate. So this is nice to see when we look at it from here. And then I switch to the plate cut model. So you can see that as soon as this is cut away from the plate, these supports rise up, and this is how they were before. Let's switch to one of these views. Okay, that will be easiest to see. So this is after cutting it away from the plate, and this is before. You can really see them spring up. And then we can see the support removal. So what will happen to the part after we remove the support? Actually, the displacement levels are a bit smaller. So the part, because before it was 1.3 millimeters, now it's about 1 millimeter. So there was some spring back on the part after a little bit in the opposite direction of the displacement. So in the end, when I print the part, I get the real desired geometry. So I can see here, and you won't see this in any other system, I can see here the original model I'm working on in the same environment, and this is the same environment where I can make changes to my design and change my support and change my orientation. It's the same environment as where I do my build simulation. I can actually see these one on top of the other, so I can see what happens. This is the original model, and this is where the part is right after it is printed, and I see them one on